All right, here's the next learning day. We're going to talk about what's called the distance formula. So we kind of already talked about what's called the midpoint formula, right? The midpoint, right? If we had points A and point B, right, we're finding literally the middle of the segment. Today we're going to talk about the whole entire segment. We're going to find the distance of the whole entire thing. Okay, we're going to find this distance. Okay, so there is a specific formula, right? It still goes with our points, right? With the midpoint formula, point A had a point B, and then we went ahead and used the midpoint formula, right? The x1s, the x2s, the y1s, the y2s, right? Same thing happens for the distance formula, okay? So it says if point A is x1 comma y1 and point B is x2 comma y2 are points on a coordinate plane. This is my coordinate plane. Then the distance between A and B is represented by this whole entire equation. Okay, it's a long one, but it's super easy peasy, guys. Okay, so let's go ahead and take a look at it, right? Point A is made up of x1 and y1. So here is x1, here is y1. From these points, let's go ahead and see where they meet. They meet right here. So this is point A. This is x1 comma y1, right? I'm going to do the same thing with point B. Point B says it's made up of x2 comma y2. So here's x2, here's y2, and I'm going to go ahead and see where they meet. They meet right there. So here's point B. This is the x2 comma y2, right? What we are going to be calculating using this big formula is the distance between the 2 points. So this distance right here, that is what we're trying to calculate, okay, using this distance formula. So let's go ahead and try example 1. It says use the distance formula to find the distance between 2 points, A and B. If necessary, it's asking us again to go around the nearest tenths place. So this is 1 place after decimal. Okay, so let's go ahead and try it. First, I'm going to go ahead and plot the points. Right, let's plot point A. Point A is 2 comma 1. So as I'm plotting, I'm going to start with my x value of 2. So I'm going to go and find 2 on my x-axis, right? 1, here's 2, right? And it looks like I'm going to go up 1. So right here, there's that point A. Right? Point B, it's saying that it's 4 comma 3. So I'm going to go and look at 3, 4. Here's 4. And I'm going to go up 3. There's that value of B. Again, we're calculating this distance. This is what we don't know. Let's calculate by using the distance formula. So I'm just going to go and copy and paste it down. I have D is equal to the square root. It's a long square root. I'm going to first start with x2 minus x1 squared plus y2 minus y1 squared. Okay, when I'm looking at my points, these x1s, y1s, x2s, y2s, that's where you go and plug it in, right? So 2 is x1, 4 is x2. So as I'm building up my equation, I have the square root of x2, which is 4, minus x2, which is 2. I'm going to close my parentheses and I'm going to square it. Right? Plus now my y1 and y2. I'm going to start with y2. y2 is 3 minus y1, which is 1. And then I'm going to close my parentheses and I'm going to square it. Okay. From here, guys, I can actually stop and I can go to my calculator. So let's go and do it. We could solve it in our head. But let's go ahead and see what happens if we just plug this whole entire thing in the calculator, right? So I'm going to start with my big square root. I'm going to literally plug in what I wrote down. So I have 4 minus, parentheses, 4 minus 2, close your parentheses, squared, plus parentheses, 3 minus 1, parentheses, squared. And I get this long decimal, right? I'm going to put that right over here, is equal to 2.828, right? Again, it's asking us to round to the nearest tenths place. So I need to see if I'm rounding up the 8 or am I keeping it, right? I'm going to look at my next number over. 2 is smaller than 5, so then I don't even pay attention to it. My answer is 2.8. Okay. Now you could go ahead and just right off the bat plug it in to your calculator, right? But we can also think about it a little bit. If I were to keep going, right, I would have to calculate 4 minus 2. What's 4 minus 2? 2, right? So this becomes 2. Quantity squared, right? Plus, and then I'm going to calculate 3 minus 1. 3 minus 1 is 2. Quantity squared. And I'm going to keep going, right? 2 squared, if I were to plug it in, that's just 4. So this becomes 4 plus 2 squared, which is 4, which becomes radical 4 plus 4 is 8, right? If I plugged in radical 8, it gives me the same exact answer, guys. It gives me the 2.8284, yada, 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 right? So you could go ahead and simplify as much as one single number digit, right? And then plug it in and get the long decimal. Or you could just take the shortcut and plug it in from here. Okay, I like to go ahead and just take the shortcut and plug it in from there. So let's go ahead and try the next example. Right, part B, it says I have 2 points, right? I have point A, which is 3 comma negative 1, and then point B, which is negative 4 comma 2. Right, so let's go and start by just plotting point A. Point A is 3 comma negative 1. So I'm going to start with my x-axis. I'm at 1, 2, 3, right? And I'm going to go down negative 1. So here's negative 1, negative 2, negative 3. Down negative 1, there's that point of A. Okay, and I'm going to look at point B. It starts at negative 4, so here's negative 1, negative 2, negative 3, negative 4. And I'm going to go up 2, 1, 2. There's that point of B, right? And same thing, I can connect the dots, and I'm finding this distance in between. That's what I'm trying to find. Okay, so let's go ahead and look at the formula. It's D is equal to the radical, the whole square root of x2 minus x1 quantity squared, plus parentheses y2 minus y1 parentheses squared, right? I'm going to start with x2 and x1. So then x2 is what? Negative 4 minus the x1, which is 3. Close my parentheses and squared. Right? Plus. Right? I'm going to start with now y2. y2 is 2. y1 is negative 1. So then this becomes 2 minus. Now y1 is negative 1, so I'm going to go ahead and put that in parentheses as well. And then I'm going to close my overall parentheses and square it. Okay. And let's just go ahead and plug this whole entire thing in my calculator. So I have radical parenthesis negative 4 minus 3 parenthesis squared plus parenthesis 2 minus parenthesis negative 1 parenthesis squared. Wow. 2, 4, negative 4 minus 3 squared, yep. 2 minus negative 1 squared. My other answer key, I did it wrong, but okay, let's keep going. Right, so then your answer is going to be, and I'm going to write all the way down here, 7.615, right? Again, I'm trying to see, am I rounding up the 6 or am I keeping it the same? Right? I'm going to look at the next number. It's 1, it's less than 5, so I don't even pay attention. Your answer is going to be 7.6. Okay, now again, like last time, we could go ahead and just continue with it. Right, I'm first going to go ahead and see if this one simplifies. What's negative 4 minus 3? That is equal to a negative 7. Quantity squared plus, then I have 2 minus negative 1. That gives me a positive 3. That's what we just calculate over here. Right, quantity squared. And then I can keep going, right? Negative 7 squared is equal to 49. Plus 3 squared is equal to 9. And then I'm going to go ahead and add 49 plus 9 is equal to the square root of 58. And let's see, let's check to see if our answers are right. No way, we get the same exact thing. Cool. So then this is your final answer. Okay. All right, that's it about the distance formula. It looks like we have a class kick slide.